In this video, we will start by understanding the meaning of percentile and quantile. Later on, we will also go through the qqnorm and the quantile function inside R. Once we understand these concepts, we would be able to make quantile plots, which are also known as qqplots. Qqplot helps in visually confirming if the variables in the model are normally distributed or not. Let us first understand the term percentile. The value of percentile ranges from 0 to 100. Suppose there is a numeric variable x in our dataset. The values in this variable are arranged in ascending order. Once the data is in order, we can find the different percentile values for this variable. For instance, the value at 90 percentile can be located by finding the number whose position corresponds to 90% of the data in this ascending sequence of numbers. In the same manner, the value at 5 percentile can be located by finding that number whose position corresponds to 5% of the data in the ascending list of numbers. Let's go through a simple example to understand percentile. Let's say there are 100 elements in a numeric variable, and we arrange these 100 elements in ascending order. The number present in the 5th position in this ascending sequence represents the 5th percentile. This is because the number present in the 5th element represents the position that corresponds to 5% of the data. In the same manner, the number present in the 95th element represents the 95th percentile, and so on. Now that we understand percentile, we can easily understand quantiles. The quantile value corresponds to the value of percentile. For instance, 0.9 quantile is equivalent to 90th percentile and 0.01 quantile is equivalent to 1 percentile. There are two more things that we should revise before going further. First one is standard normal distribution and second is standard deviation. We will first go through standard normal distribution. Let's say we have a numeric variable and we subtract each value in that variable with the mean of the variable and make a distribution of the resulting values. This distribution can be referred to as a standard normal distribution. This is because we standardized all the elements in this distribution by subtracting them with the mean of the variable. Since the distribution is a standard normal distribution, at 0.5 quantile or 50th percentile of this distribution, we would have values that are either 0 or near to 0. If you think about it, for a normally distributed variable, the values at 0.5 quantile are near to the mean of the variable. And since we subtracted each of the values in this variable with mean, the value at 0.5 quantile would either become 0 or near 0. Now let us revise the process of calculating standard deviation. Again, let's assume we have a numeric variable in some dataset. For calculating standard deviation of this variable, the first step is to subtract each value of this variable with the mean of the variable. The second step is to square the individual differences and add all these squared differences. Then the third step would be to divide this value with its degree of freedom. Finally, the square root of this value would be the standard deviation of the variable. Now let us get to the main point. Let's say we have a variable that is needed to be included in the regression model. We can calculate standard deviation of each of the elements present in this variable that corresponds to a given quantile. For instance, I might be interested in finding the standard deviation value of that element in this variable which is present at 0.95 quantile. If for instance, we find out that the value at 0.95 quantile is having a standard deviation of 3, we should be alarmed. This is because 95% of the values in a normally distributed data should be within 2 standard deviation. So this way, we can tie the concept of quantile and normal distribution. If the properties of our variable are not matching with the properties of a normally distributed data, then the variable must not be used for making a regression model. In the next video, we will see how to make a qqplot. In this plot, we place standard deviation values of a normally distributed data against the values of that variable which we want to include in the regression model. By looking at that plot, we can check whether the distribution in the variable is close to normal or not. All the variables that are part of a regression model must have standard deviation values that corresponds to standard deviation values that are seen in normally distributed data. If the elements in a variable are not having standard deviation values that are indicative of a normally distributed data, we have to check that variable before including it in the regression model. We will now look at the qqnorm and quantile function inside R. Let us first look at the qqnorm function using an example. Suppose you have a normally distributed variable with a mean of 0 and standard deviation of 1. You can provide this variable to the qqnorm function. The qqnorm function would return the standard deviation value of each of the elements in this variable. Here, I have created a data using the sequence function and passed it to the qqnorm function. The sequence function generated 99 numbers starting from 0.01 to the final number 0.99. These numbers are incrementing by 0.01 units. The qqnorm function would look at these 99 values and return their standard deviation values. Since we have not provided the mean and the standard deviation argument, the qqnorm function would default these values to a mean of 0 and standard deviation of 1. The value returned are the standard deviation values for each of the 99 numbers. Now, let us look at a practical use of qqnorm function. For this, load the income dataset to R using the read.csv function. I am going to take apart two columns, mweekly and fweekly, and save them inside income data 1. Let us use the qqnorm function to check the variable mweekly. We will first check the range of this variable. As you can see, the values in this variable range from 401 to 2251. Now, we would find the mean and standard deviation of this variable. We will use these mean and standard deviation values inside the qqnorm function. Using the qqnorm function, we are first asking for 0.01 quantile or 1 percentile of a normally distributed data with mean of 1018 and standard deviation of 413. The value returned is roughly 56. In the same manner, we want the 0.99 quantile or 99 percentile of a normal distribution with mean of 1018 and standard deviation of 413. This time, the function returned a value of 1980. If you recall, the range of the variable mweekly is between 400 to 2250. According to qqnorm function, the 99th percentile of this variable should be 1980 if it is normally distributed. So, we will investigate those values in the mweekly variable whose value is more than 1980. As you can see, there are two rows that meet this condition. We will investigate these two rows for their correctness. We will now go through the quantile function. The first argument of the quantile function is the variable whose quantile values we want. For understanding the function, I am creating a random dataset using the rnorm function. Rnorm function would return 200 random numbers from a normal distribution having a mean of 0 and standard deviation of 1. We will supply this dataset of 200 elements created using the rnorm function as the first argument to the quantile function. The second argument in the quantile function is props that requires the quantile values. The quantile function would assign these quantile values to the data in the first argument. Using the sequence function, I have created 99 quantile values. The quantile function would therefore assign these 99 quantile values to this data. Let us understand the steps performed by the function. First, the quantile function would arrange the 200 random numbers created using the rnorm function in ascending order. After this, the function would assign quantile values specified through the props argument to this data. For instance, if you look at the output, at 0.01 quantile or 1 percentile, the value mentioned is roughly -2.2. It means when the 200 numbers are arranged in ascending order, the elements in the data which is present at 0.01 quantile is minus 2.2. Let us see one more example. This time we will use the mweekly variable in the income dataset. As you can see, there are 141 entries in this variable. We want to generate the quantiles for these 141 values in this variable. So inside the quantile function, we would provide the variable mweekly as the first argument. Second argument would be the quantiles that we wish to find for our data. Again, the function would arrange the values in mweekly in ascending order and assign quantile values in the second argument to this data. We will continue this discussion regarding quantiles in the next video, where we would be looking at the qqnorm and the qqplot function.